Okay, Miss Howard's chemistry class. This is a series of videos I'm making just to help some people with the calculations. Those of you maybe who need some extra help, you need to go over it again. Maybe you missed this section, you were absent, you need to go over it that way, or maybe you're on homebound, or it could possibly be you did something really stupid and got yourself into DAEP or something like along those lines. So this is for you guys who need some extra help on that. This is the first of the series. It's over moles, molecules, and grams. And at C8A, I will define and use the concept of a mole. These are the TEECs, the SEs that the state of Texas says you guys have to know. In C8B, I will use the concept to calculate the number of atoms, ions, or molecules in a sample of a material. Okay, so what you need to do is you need to get a calculator, you need to get some paper, you need to get your periodic table, maybe your yellow pages. Go to my website, www.mshoward.com, and click on Chemistry, Unit 1, and print the worksheet that has the chemical calculations, moles, molecules, and grams. And the first page has the problems that are on this PowerPoint. The second page has practice problems. They are the same problems, only I've changed the numbers on them. So it'll help you kind of get accustomed to what we're doing here. You may have to pause the video that we're doing right now so that you can pop things into your calculator. Because I've already done it in mine, so I've got the answers already prepared. Be willing to pause, and you need to make sure that you put it into your calculator to make sure that you're getting the same answer that I'm getting on here. Okay, so on all of these conversions, moles, molecules to grams, and vice versa, you have 4 basic steps. You know, and some teachers will give you more, some less, but these are the 4 basic steps that make sense to me. So number 1, write the given. So you're going to read the problem, obviously, and something in there, they have to give you some piece of information, some number. And so you write the given. Number 2, draw your grid. That's the little dimensional analysis grid. Some people call it a T-chart. Number 3, choose which of the 2 conversion factors you're going to use. They're listed right up here at the top. 1 mole is equal to 6.02 times 10 to the 23rd particles, and that's equal to the molar mass. Remember that the molar mass we get off of the periodic table. 6.02 times 10 to the 23rd particles. Those particles might be atoms or ions or molecules, formula units, or 1 mole. And it's always 1 mole is equal to something. That number that's associated with the mole right there is always 1. Step 4, multiply once you have your conversion factors chosen. Multiply across the top and then divide by what's on bottom. So we'll start with me getting my pen and hoping things are going to work properly here. Okay, so we have a problem. How many grams do 1.43 times 10 to the 20 atoms of polonium weigh? So my step number 1 is write the givens. So I've got, let's find it here. There we go. Got 1.43 times 10 to the 23rd atoms. I'm just going to put 18 of my element is polonium. You need to get in the habit of writing everything down there, what the unit of measurement is and what element or compound it is, because we will also be changing from compound to compound. So you need to get in that habit. Second step, I draw my grid. Third step, I need to choose my 2 conversion factors. Well, right here, whatever is right here, it's atoms, ions, particles. I absolutely know that I'm going to use Avogadro's number. So, and it has to go right down here because I want it to cancel. So I'm going to put Avogadro's number down here. 6.02 times 10 to the 23rd, and we're talking atoms in this particular case of polonium. 6.02 times 10 to the 23rd atoms of polonium, and I need to figure out how many grams, because in the problem they're saying how many grams. So I don't want 1 mole, I want the molar mass of polonium. So you look on your periodic table, and the molar mass of polonium, and I'm going to round to the nearest whole number, is 209. So I've got 209 grams of polonium. Now look and see what cancels out. Atoms of polonium on top, atoms of polonium on bottom, they both cancel. So my only unit of measurement left is grams of polonium. Multiply across the top, divide by what's on bottom, and we find that if you have 1.43 times 10 to the 23rd atoms of polonium, it will weigh, let's see, 0.05 grams. Okay? And then we can move on to the next one. And again, pause this whenever you need to. Number 2, if you want 4.5 times 10 to the 22 molecules of Na3PO4, how many grams do you weigh out? That should be weigh out on the scales. Well, you go back up here, and first of all, you guys should remember how to name these things. Here is an ionic compound. I know it's ionic because it's a metal bonded to some nonmetals. I know that it's got a polyatomic ion because I see more than 3 element symbols up there. Name the first element. Name the polyatomic ion. So we have sodium. Look on your yellow pages on your star chart. They're on yellow paper for my class, so just find out whatever color paper it is. So sodium, and then you can look on your star reference materials for chemistry and find this polyatomic ion. Its name is phosphate, so sodium phosphate. So step 1, I'm going to write down what they gave me, and they gave me 4.5 times 10 to the 22nd molecules, and I'm going to put mlcl. Okay, that's a C and an L. All right, yeah, I know. And I'm going to put my stuff in Na3PO4. Draw my grid, step 2. And then step 3, I need to figure out what is it I've got going on here. Well, I know since this is molecules, and you can tell, molecules are always going to have some big, huge number there, like 10 times 10 to the something or other. And so I know that I'm going to use Avogadro's number down here. So I can already write it 6.02 times 10 to the 23rd. And in this case, I'm seeing molecules here, but in reality they're formula units. But I'm going to go ahead and just go ahead and put molecules right down here. Na3PO4 because I feel like it and I can. We all know, yes, they're formula units. Oh, crud. Let's see if we can just get rid of that. Oh, there it went. Okay, so, and then up here, I have to figure out what I have up here. Well, what's it asking me for? How many grams? The only place I've got grams up here is where it says mass. So I have to get the molar mass of this Na3PO4. How many NAs are there? There are 3. Look on the periodic table. And sodium is 23 grams. So 23 times 3. And then plus how much 1 phosphorus weighs. Plus however much 4 oxygen weighs. And all that together should equal 164 grams of Na3PO4, sodium phosphate. When you pop it into your calculator, multiply across the top, divide by what's on bottom, and we end up with 12.26 grams of sodium phosphate. Okay? You guys really need to pause now and pop this into your calculator and make sure that you're coming out with the same answer that I am. Maybe I got one of these wrong, and you need to check it and make sure and tell me in class if I have one wrong. I appreciate it if you do. Okay, number 3, what's the mass of 0.38 moles of cobalt? Number 1, write the given. Stop that nonsense. 38 moles of cobalt. Notice it's capital C, little o. A lot of you guys have problems remembering how to write your symbols, or you're just sloppy when you're writing, one of the two. Be careful and write it properly. All right, so we've got 0.38 moles of cobalt. So I need to know step 3, I need to choose my conversion factors. I want to go from moles, right they gave me here, to mass. Mass is grams. So that means I've got 1 mole down on the bottom. If I have 1 mole of cobalt, it's equal to whatever the molar mass of cobalt is on the periodic table. And it looks like, if I round it, that it's 59 grams of cobalt. Notice that moles of cobalt cancel out on top and bottom. And I have 22.42 grams of cobalt. Now, I typically tell you guys that you need to keep 2 digits to the right of the decimal on each of these. And so we're not worried at this moment about significant digits. And we'll save significant digits for a different time other than what we're doing right now. Okay, next one, let's see, number 4. If you have 2.81 moles of calcium chloride, how many grams do you have? 2.81 moles of CaCl2. How do I know that's calcium chloride? Name the first element. Name the second element with the ending change to IDE. Okay, step 3, choose which two conversion factors. Moles are right here. I've got to get them to cancel out, so I know 1 mole has to be down here. 1 mole of calcium chloride is equal to, are they asking us for grams? Yes, they are. The molar mass from the periodic table. The molar mass of calcium chloride from the periodic table is 110 grams. Calcium once, calcium weighs 40 grams. Chlorine twice, chlorine will just round it to 35 each time. So 35 and 35, 70 plus 40. Oh, that would be 110 grams of calcium chloride. So we have moles of calcium chloride on top and bottom. So our answer has to be in grams of calcium chloride because that's the only thing we have left. Multiply across the top, divide by what's on the bottom. So we end up getting 309.1 grams of calcium chloride. See, it's not too difficult at all. Yep. Moving on to the next one. Again, you can always pause this if you're not sure about something and go back and listen to it again. How many atoms of palladium are in 400 grams of palladium? So 1, write the given. 400 grams of palladium. 2, draw the grid. 3, choose your conversion factors. All right here. I've got grams here. That means I'm going to have the molar mass. Mass is grams. So I look on the periodic table, and palladium has a molar mass of 106 grams. And it's asking me how many atoms. Whenever they ask you how many atoms, particles, molecules, formula units, ions, you always have to use Avogadro's number. When they ask you how many atoms, you can always bet that you're going to have this huge, massive number of atoms. So it'll be something times 10 to the something. It'll always be like that. Atoms of palladium. Multiply across the top, divide by what's on bottom. Be careful when you're using Avogadro's number. Don't use the caret button. Don't type in the times 10 twice. So when you type it in your calculator, it's 6.02 second EE 23. So all you type in there. And that means your calculator sees it as one number, the whole thing, as one number, rather than, oh, there's 6.02 and times the second number, 10 to the 23rd. Okay, so multiply across the top, divide by what's on bottom, and we have 2.27 times 10 to the 24. Atoms of palladium. Now, if your exponent is off by 1, that probably means you typed in the times 10 when you weren't supposed to. So if you're using that second EE button, it's typing in the times 10 for you. Okay? Number 6. If you have 2.95 grams of K2S, how many formula units do you have? Again, formula units, that's what we call them when we're talking about ionic compounds. A lot of times we get lazy and we just call them all molecules. So K2S, what is that? Name the first element, then name the second element with the ending changed to IDE. So potassium sulfide. Alright, so if you have 2.95 grams, alright, let's write that down. 2.95 grams of K2S. Second, draw the grid. Third, figure out which of the conversion factors we're going to use. We've got grams, so we have to have grams down here, and the only way we get that is looking at the molar mass. And it looks like the molar mass of potassium sulfide is 110 grams. You know, you might check me on that because that seems pretty convenient that it's the same as what it was. K2S. Alright, so we have 110 grams of K2S, and then what do I put on top? What's it asking me for? How many formula units or molecules? It means I've got to use Avogadro's number. 6.02 times 10 to the 23rd. Let's put formula units. I'm just going to put form of K2S, right? So what cancels? Grams of K2S, grams of K2S. Multiply across the top, divide by what's on bottom, and we should get 1.61. If you stop there, 1.61, and you put that as your answer, it means you haven't read the whole number off your calculator. Times 10 to the 22, and that would be formula units. I'm not gonna put FU on there. Formula units of K2S. Alright? Number 7. How many potassium ions are there in 6.88 grams of K2S? Alright, this is one that's just almost verbatim off of the STAR test questions that they were sent out to us. So the first thing I need to do is I need to write down what they gave us, 6.88 grams of K2S, and we said that it had a formula mass of 110. So again, grams down here, 110 grams K2S. And you know what? We know they're still asking for ions. We're going to use that Avogadro's number again. And it's going to be of K2S, formula units. Okay. Multiply across the top, divide by what's on the bottom. And I'm getting, let's see, pop it into my calculator too. So 6.88 times 6.02 divided by 110. And I'm getting 3.7 times 10 to the 24th. Let's see. I'm going to erase that and pop it in again, just to be on the safe side. 6.88 times 6.02 divided by, and I've got 3.77 times 10 to the 22. Here it is. 3.77 times 10 to the 22 formula units of K2S. Is that what they asked us for in the problem? No. They asked just for the potassium ions. So look up here. For every one of these units, these formula units, I have 2 Ks within it, right? It'd be like for every one human body, there are 2 arms. So if I have 3.77 times 10 to the 22 units of the whole thing, then if I multiply that by 2, I'll get how many potassium ions are in there. So take your number that you have, 3.77 times 10 to the 22, keep wanting to put 23, and then times 2. And it looks like we've got 7.54 times 10 to the 22 potassium ions. Okay, did you guys see that? So it's kind of like, again, even taking a sandwich. If you've got 16 sandwiches, then if you look at all those 16 sandwiches together, don't you have 32 pieces of bread? If it's just your typical standard sandwich, don't go cycle and make some weird sandwiches somewhere, okay? So it's just saying, hey, but within that, there are double this number of pieces in here. Okay, next one. How many moles of zinc, this is number 8, are in 2.84 grams of zinc? Write down the given. 2.84 grams of zinc. And they want to know how many moles of zinc that is. Okay, so moles of zinc. What do I put down here? Well, it's got to be in grams. That means I've got to go to the periodic table. And zinc has a molar mass of 65. And it wants moles. So if I have 1 mole of zinc, it weighs 65 grams. Grams of zinc are on top and bottom to cancel out. So 2.84 times 1 divided by 65. And it looks like we have 0.04 moles of zinc. Let's see, number 9, same kind of question. If you have 17.62 grams of FeCl3, how many moles do you have? Okay, so FeCl3, we know it's iron, right? And we know it's chlorine. So you would think immediately that it's iron chloride. Yeah, but remember, iron's one of those guys in one of those transition metals in the middle, and they don't have the nice spiffy little oxidation numbers that most of them have. They can have more than one. In this case, what we have to do is kind of use the backwards crisscross method. If we pull this 3 up, we would have had iron as a +3, and this 1, since there's no number, we say it's a 1, goes back up here, and chlorine would have been a -1. We look on our periodic table, and sure enough, chlorine is a -1, so that means we have iron 3 chloride here. So write down the givens. They give us 17.62 grams of iron 3 chloride. Second, draw your grid. Third, choose your units. You're going to choose your conversion factors. And I've got grams here, so I look on my periodic table. There's 1 iron and 3 chlorines. If I can find that, there it is. Looks like it's 161 grams of iron 3 chloride. And it's asking me for moles, so it's got to be 1 mole. 1 mole of iron 3 chloride is equal to 161 grams of iron 3 chloride. Multiply across the top, divide by what's on the bottom. You notice how I had you draw the grid and everything consistently over and over again. And the reason for that is, rather than just saying, oh yeah, you just divide, the reason for that is our problems are going to get more complex. And it'll be more important to actually have it set up in this grid so you know what it is that's going on. So let's see. Looks like I've got 0.11 moles of FeCl3. Number 10, how many moles of nickel are in 3.88 times 10 to the 25 atoms of nickel? Write down the given. Atoms of nickel. Next, draw the grid. Third, choose your conversion factors. We've got atoms up here, so we know we're going to have to use Avogadro's number. Atoms of nickel. And it's asking us how many moles. Well, if you have 6.02 times 10 to the 23rd particles of something, that's 1 mole. And in this case, we're talking nickel. So my atoms of nickel cancel because they're on top and bottom. Multiply across the top, divide by what's on the bottom. And it looks like we have a lot of nickel atoms, or a lot of moles of nickels. 64.45 moles of nickel. That's a lot. Next, if you have 6.79 times 10 to the 25 formula units of AgNO3, how many moles do you have there? So name the first element. Name the polyatomic ion, silver nitrate. So we have 6.79 times 10 to the 25. I'm going to cheat and just put molecules because it's easier to write. Molecules of AgNO3. Draw my grid. And now, I'm going to use, since I'm talking molecules or formula units here, I know I've got to use Avogadro's number, 6.02 times 10 to the 23rd. Formula units of AgNO3. And what's it asking me for? It's asking me for moles. So I've got to have 1 mole of AgNO3 on top. Multiply across the top, divide by what's on the bottom, and it looks like I have 112.79. Oh my goodness. Moles. Moles it is of silver nitrate. That's, buying silver nitrate to use in class, that's a lot. That's pretty expensive. Notice the molecules or formula units of silver nitrate cancel out on top and bottom. So my only unit left over here is the moles. Number 12, 2 more, number 12, number 13. Looking at number 11, how many moles of oxygen atoms do you have? Well, let's go back and look at number 11. Just the oxygen atoms. If we have 112 moles of the whole thing, silver nitrate, notice within that, don't we have 3 of those for every 1 unit that we have? It's kind of like saying if we have 1 mole of this, we'll have 3 moles of oxygen within it. Again, if we have 1 sandwich, we could have 2 pieces of bread in there. Okay? So same kind of thing. So really what we're going to do is we're going to take that number and we're going to multiply by 3. So that 112.79 moles of AgNO3. We could even set it up in an interesting way here too. Yep. So I want moles of AgNO3, so I'm going to go ahead and draw my grid. For every 1 mole of AgNO3, I have 3 moles of the oxygen within it. Yep. So for every 1 of the whole units, I've got 3 pieces or 3 moles of oxygen. So this number times 3. Notice the moles of AgNO3 cancel out. And notice, look here, all we have left are moles of oxygen. So if we take that number and multiply it by 3, we've got something that I need to pop into my calculator. 112.79 times 3, 338.37. What did I say? 8.37 moles of oxygen. Okay, last one. So here we have, find the number of moles of NaHCO3. Now, common name is baking soda, but again, we can name it the same way. Here's sodium, and then that polyatomic ion right there, hydrogen carbonate. Okay, or an old name for it is bicarbonate, so sodium bicarbonate. All right, so we drop on down here and we write down what the given is. So 145 grams of NaHCO3. We want to change it to moles. Moles and moles and moles. So that means I have got to have grams down here. That means I've got to have the mass here. Formula mass of NaHCO3 is 84 grams. And you guys, again, you're going to have to check me on this stuff because I kind of went through this fast here. And I want to go to moles. So if I have 1 mole of NaHCO3, it's going to weigh 84 grams. Multiply across the top, divide by what's on bottom. Notice grams of NaHCO3 cancel out on top and bottom. So my answer is going to be in moles. It looks like I've got just almost 2 moles, 1.73 moles of baking soda. Hallelujah. Okay, so what we've done is we've gone through all of these examples. And what you need to do now is practice on your own. Have a pleasant evening. Maybe. There we go.